2.5, we're going to talk about the fundamental theorem of algebra. So the fundamental theorem of algebra states that if we had something like x to the 5th power, whatever the highest degree exponent is, that's how many zeros we're going to have as our answer. So we'd have 5 zeros. It may happen that not all of them are real zeros. They could all be imaginary zeros, but we'd have 5 zeros. So it says in the complex number system, we'll have precisely that many zeros. So they could be irrational, they could be imaginary, but they still count as zeros. Next, the linear factorization theorem. For every zero that we have, you can write out the complete factorization of it, even if it's a complex number. So let's say I had something like x squared plus 1 equals 0. How would we solve here? Subtract the 1. So x squared equals -1. Take the square root of both sides. So what does x equal? Just I? Plus or minus I. We took the square root of both sides, so we need the plus or minus. If we wrote this in complete factorization or the linear factorization, we'd write x minus I and x plus I. So it's always x minus whatever the 0 is that we get. Example 1 says find the zeros. So this is just solving. We want to change f of x to be 0 and solve. How would we solve for a? Thank you. Add 2. So x equals 2. Great job. B. Make this 0 and solve. Here we have to factor. What are 2 factors of 9 that add to -6? -3 and -3. So we've got x minus 3 and x minus 3 equals 0. Set them both equal to 0, so what does x equal? +3. So x equals +3. We actually have 2 x equals +3, so if we graph this, we'd have multiplicity. What would our multiplicity be? We'd have multiplicity of 2. So at 3, our graph would touch and turn. So it'd look like this. For C, we'd change f of x to be 0. What would we do to solve here? Take out an x. When we take out an x, we're left with x squared plus 4. Can we factor this anymore? Nope. So we're just going to set both pieces equal to 0. So x equals 0. That's one of our answers. How do I find the other? Subtract 4 to both sides. So we get x squared equals -4. Take the square root. What does x equal? Positive and negative 2i, because we take the square root of 4. So this would be our other 2 answers. So notice how in A, we had x to the 1st power, so we have 1 answer. In B, we have x to the 2nd power, so technically we had 2 answers, because we had a multiplicity of 2, even though they both ended up being the same answer, but we still had 2 solutions. In C, we had x to the 3rd power, so here we had 3 solutions. We had 2i, -2i, and 0. How many solutions do you think we're going to have in D? 4. So let's solve. What would we do to solve here? Does it factor? What does it factor into? X squared plus 1 and x squared minus 1. Can we factor this anymore? Yeah, x squared minus 1 factors into what? X plus 1 and x minus 1. So we've got x squared plus 1, x plus 1, and x minus 1. Once we factored all the way, we can set each piece equal to 0 and solve. So we've got x squared plus 1 equals 0. subtract 1. X squared equals -1. Take the square root. What does x equal? Plus or minus I. Perfect. So that's 2 solutions there. What does x equal in our other ones? Awesome. X equals -1 and x equals +1. So those would be our 4 answers here. Next, we're going to talk about the rational zero test or the rational root test. This helps us find all the possible solutions of our polynomial that we're given, but just the real possible solutions. So if we have a real zero, we'd use this to help find that real zero. So to find our possible options, we find factors of the last over factors of the first term, or factors of the leading coefficient. So factors of the constant over factors of the leading coefficient. This gives us all the possibilities that we could have. They're not all going to be zeros of our polynomial, but we have to test them and see if they are zeros. So to test them, we use synthetic division. What do you think we're looking for when we use synthetic division to see if it's a factor or not? Awesome. If the remainder is 0, then it's a factor. If you get a number for a remainder, it's not a factor. You can cross it off the list. It's not going to work out. So we're looking for the remainder to be 0. So the remainder has to equal 0. If the remainder equals 0, then it's a factor. So in our rational zero test, we find our possible rational zeros by finding factors of the constant term, and it's always the positive and negative of the numbers, and factors of the leading coefficient. So again, the positive and negatives of these numbers. So in example 2, we want to find the rational zeros of our function here. So can we factor this? Nope. If it doesn't factor, then we have to use our rational zero test, or you can call it last over first, or P over Q. So I'll call it P over Q. So what are factors of our last term? 1. So plus or minus 1 over factors of our leading coefficient. What are factors of our leading coefficient? Plus or minus 1. So if I were to write out all of my possible options here, I've got +1 and -1. So I'm going to use synthetic division and see if one of these are a 0 of my polynomial. So we have to test them both out. What's going to go inside the box? 1, 0, 1, 1. Awesome. Don't forget about the 0. We're missing that x squared term, so I have to put a 0 in that spot. What do you want to try first, +1 or -1? Sure, let's try -1. We're going to drop down the 1, multiply, we get -1, add -1, multiply, this would be 1, add 2, -2, add -1. Did we get 0 as the remainder? No, so -1 does not work. It is not a factor, not a 0. Let's try +1 now. So drop down the 1, multiply, you get 1, add 1, multiply, 1, 2, 2, 3. Does 1 work? Nope, 1 is also not a 0, not a factor. Doesn't work, we didn't get 0 as the remainder. So what do you think? Do I have any real zeros here? Nope, we've got no rational zeros. Let's do the same with example 3. So here it doesn't factor. You can try to factor by grouping, but it's not going to work out because the insides won't end up being the same. So we're going to use P over Q, our last over first. What are factors of our last term? Plus or minus 1 and 3. Awesome. What are factors of our first term? Plus or minus 1 and 2. Perfect. So if I listed out all of my possible zeros that I have here, I've got positive 1 over 1, which would be 1. Negative 1 over 1, so negative 1. 3 over 1 and negative 3 over 1, so 3 and negative 3. Now we also have 1 over 2. So that would be positive 1/2 and negative 1/2. And then 3 over 2. So positive 3 over 2 and negative 3 over 2. My suggestion would be always do synthetic division with the whole numbers first. It'll be easier to do the math, and then if one of them works, you'll end up with something smaller, and hopefully you can factor it. So I would stick to trying the whole numbers first. Once we break down our polynomial here, our function, then we can see if we can factor it after that. So we're going to do synthetic division, see what works. Inside the box, I've got 2, 3, negative 8, and 3. What do you want to try first? Sure, we can try 1. Drop down the 2, multiply, we get 2, 5, 5, negative 3, negative 3, 0. Does it work? Yes, our goal was to get 0 as the remainder. So 1 is a factor. I'm going to say x equals 1. Perfect. How many zeros am I going to have here? I'm going to have 3. We're looking for 3. And I've already got one of them. So now I only have 2 more. You can do last over first again. But since we started with x cubed, our answer down here is going to be 2x squared plus 5x minus 3. Once you get to an x squared to quadratic function, just factor it. See if it factors from here. How would we factor this? I'm going to multiply the first times last. So we get negative 6. What are 2 factors of negative 6 that add to 5? Positive 6 and negative 1. Perfect. So we've got x plus 6 and x minus 1. Since I started by multiplying that 2, I have to remember to go back in and divide it. So we've got x plus 3 and 2x minus 1. Set them both equal to 0. So x equals negative 3 and x equals 1/2. So those would be my other 2 zeros, negative 3 and 1/2. What if we got here to an x squared function and it didn't factor? What would we have to do? The quadratic function. The quadratic formula. We would do the quadratic formula. So if you get to an x squared term and it doesn't factor from there, it could just be that your zeros, the remaining zeros aren't going to be real zeros. They might not be rational, so you'd have to do the quadratic function, the quadratic formula. There's a couple questions on the WebAssign that give you a graph and say find the zeros. We know if we're given a graph that looks like this, wherever our graph crosses the x-axis, those would be our zeros. So keep that in mind for the homework. If it gives you a graph, you can see what your x-intercepts are. Those would be your zeros of the function. When we have complex zeros occur in conjugate pairs. So we kind of talked about this a little bit in one of the earlier sections in chapter 2. But if I had something like square root 5, square roots and i's are complex. So square roots and i's. If I had something like square root 5 as one of my zeros, its conjugate pair would also be a 0. So I would also know that negative square root 5 is one of my zeros of the function. If I had something like 2 plus 3i as one of my zeros, what would another 0 be? 2 minus 3i, awesome. The conjugate pair would also be a 0. So complex zeros occur in conjugate pairs. So in example 4, it asked us to find a 4th degree polynomial function with real coefficients that has -1, -1, and 3i as zeros. Do we know of any other zeros that we have that would be a pair of one of these? Are any of these complex? 3i. So what would another 0 be? -3i. Awesome. So if we had a 4th degree polynomial, it's going to end up being x to the 4th power. We need 4 zeros to multiply it all out. So when I write this, I'm going to start by putting it in factored form. So it's always x minus the number. So x minus -1 would be x plus 1, x plus 1, x minus 3i, and x plus 3i. We're going to FOIL this out to come up with our polynomial function. Always start with the conjugate pair. It's going to make it so much easier. Start by multiplying out your conjugate pair. And since these are conjugates, we can do our conjugate shortcut. A squared minus b squared. So we've got x squared minus 3i squared. Don't forget we have to square the 3 and square the I, so this would be x squared minus 9i squared. And what does I squared change to? Change to -1, so it makes it a plus 9. So we've got x squared plus 9. Now the order that we multiply the remaining ones out doesn't matter. If you wanted to multiply x plus 1 to x squared plus 9, you could do that. Since these are already right next to each other, I'm going to multiply these two together now. So we've got x squared plus 2x plus 1. So now we can multiply our two answers together. So everything is going to end up getting multiplied together here. So make sure when you multiply everything in your first set gets multiplied to everything in the second. Starting with x squared times x squared would be x to the 4th power. X squared times 9 would be 9x squared. 2x times x squared would be 2x cubed plus 18x plus x squared plus 9. Then we just want to combine like terms. So we've got x to the 4th power plus 2x cubed. I'm going to combine my x squared, so that would be plus 10x squared plus 18x plus 9. Very last thing we have to do is just name it as a function. Just put your f of x there. So this would be our answer. We started off with 4 zeros and ended up with x to the 4th power. Yes?
When you do a squared minus b squared, is it like the first term? Like what's the a and what's the b?
So like your conjugates are separated by a minus and a plus. So what's in front of the minus and plus would be your a. What's behind it would be your b.
Oh, okay. So if it's negative on like one side, it doesn't matter if you do.
It doesn't matter because it's always going to be like, it's always going to be a plus and a minus.
Oh, okay.
So you're just using the term.
Got it.
So complete factorization would be, it doesn't matter what your zeros are. You can leave your i's as i's and square roots as square roots. But if the question asks for something to be left as irreducible over the reals, it would want your factor to be like the step before you got the imaginary answers. So something like x squared plus 1 is irreducible over the reals because you can't reduce it anymore and still have real numbers. on the bottom, we've got x squared minus 2. So that factors into x minus square root 2 and x plus square root 2. This is irreducible over the rational. So we can't reduce it anymore and still have rational numbers. So we would just leave our factor. If the question asks to leave your answer irreducible over the rationals, you just leave your factor as x squared minus 2. Example 5 says to find all the zeros given that 1 plus 3i is a zero of our function. So if 1 plus 3i is a zero of our function, do we know of any other zeros that we'd have? Awesome, the conjugate pair. So 1 minus 3i would be a 0. Now let's find what the factor of it would be, not just the 0, but with the x, and then we can divide to find our other remaining factors. So let's put this into factored form. We've got x minus our 0, so x minus 1 plus 3i, and x minus 1 minus 3i. Now we have to be careful here because we have two terms. It's not just x minus a number. So I'm going to distribute the negative. Let's get rid of those parentheses on the inside. We'll simplify it a little bit. So we've got x minus 1 minus 3i and x minus 1 plus 3i. Now these are conjugates of each other. We've got a minus and a plus. So x minus 1 minus 3i, x minus 1 plus 3i. So we could use our conjugate shortcut, a squared minus b squared. What would our a be here? X minus 1, perfect. So we've got x minus 1 squared minus, what's our b? 3i. So minus 3i squared. So x minus 1, we've got to FOIL it out. We get x squared minus 2x plus 1 minus 9i squared. Well, what does I squared change to? Negative 1, which makes it a plus 9. Awesome. Then we can combine our like terms. So we've got x squared minus 2x plus 10. Not quadratic formula. We're going to divide. We can't use synthetic division here because it's an x squared that we're dividing into it. But thinking about it with whole numbers, if I had something like 104 and 2 was a factor, how would we find the remaining factors? You'd divide. So how many zeros are we looking for total here? We're looking for 4 total. We already have 2, so we need to find our other 2. So we're going to do synthetic division, or we're going to do long division to find them. So outside the box, we've got x squared minus 2x plus 10. Inside, we're going to put our whole polynomial in there. X to the 4th power minus 3x cubed plus 6x squared plus 2x minus 60. We're not missing any terms, so we don't have to put zeros in there. We're good. What's x to the 4th power divided by x squared? X squared. So I'm going to put that on top of my x squared term. I'm going to multiply x squared times everything out front. So we get x to the 4th power minus 2x cubed plus 10x squared. What do we do next? Change the signs and combine. So x to the 4th power cancels. This would be negative 1x cubed, so negative x cubed minus 4x squared. Then we divide again. What's negative x cubed divided by x squared? Negative x. Then we multiply by everything out front, so we get negative x cubed plus 2x squared minus 10x. Change the signs and combine. X cubes cancel. This would be negative 6x squared plus 12x. The same thing, we're going to divide. Negative 6x squared divided by x squared. Negative 6. We're going to multiply negative 6 times everything out front, so negative 6x squared plus 12x minus 60. Change the signs and combine. 6x squareds cancel, 12x's cancel, and negative 60 plus 60 would be 0. So do we have a remainder? No. We knew that x squared minus 2x plus 10 was going to be a factor. So if you did this correctly, you will not get a remainder in this step. It will always divide in evenly. So when you do this, when it gives you a factor of it, if it gives you a 0, you find your factor and you divide, it will always divide in evenly because we knew that it was going to be a factor. So now our remaining factor is x squared minus x minus 6. How do we find our zeros from here? What are two factors of negative 6 that add to negative 1? Negative 3 and 2. So x minus 3 and x plus 2. So x equals what? 3 and negative 2. So if I were to list out all of my zeros here, I'd say x equals 3, negative 2, 1 plus 3i, and 1 minus 3i. There's a couple questions like this on the WebAssign. I'm pretty sure, just make sure you read the directions for the WebAssign to find out what it's asking. I think for this question, or a question like this, it says list all the zeros, so it wants you to list the one that's given also. Kylie?